This conference will now be recorded.
So, very good evening, students. We are discussing numerical problems from previous year's JEE papers on this particular topic, current and electricity. So today we have picked up few questions from the chapter, from IIT JEE papers 2019, JEE Mains paper. Okay, so let us read the problem. A wire of resistance R is bent into a form of a square ABCD, as you see here. The effective resistance between E and C, where E is midpoint of the arm CD. Okay, so question is very simple. You have to find out the effective resistance between E and C, these 2 points. So if I connect a battery across this, what would be the effective resistance between these two, E and C? So here there was a wire. Suppose the whole length is to be L. Suppose the whole length of the wire is L. Now when you just form the whole wire into the form of a, if you just make this in the form of a square, then since the resistance is directly proportional to the length of the wire, see all these sides will carry the same amount of resistance. This is R by 4, this is R by 4, this is R by 4. Now this E being midpoint, so this DE will carry R by 8 and this will carry R by 8. Okay, now you have to find out the effective resistance between these 2 points. Look, always what we have to do, we have to try to draw an equivalent circuit for this particular arrangement. Then we'll try to do the calculation. So look, this figure, the equivalent figure can be this one. Okay, see these 2 points E and C are here. So as I was showing you there, this is E and this is C. If you connect a battery between these two E and C, see this particular part, okay, this particular part, that means DE, DA, AB, BC, okay, they will be in series, and the effective resistance of ED, DA, AB, BC, this part, effective resistance of this whole part up to E to C, this side, okay, E to D, D to B, B to C, these are in series. As you see here, you can find out the effective resistance that will be actually in parallel combination with this particular part. Okay, this particular part. Okay, so it is very simple problem. So you can see this is, so equivalent resistance of this particular part will be, so actually I have R by 8 plus R by 4 plus R by 4 Then we have R by 4 again, R by 4 again. So if you do LCM, this is 8 R plus 2 plus 2 plus 2. Okay, these are okay. So this is 1 plus 2 plus 2 plus 2 and multiplied with R. All right. So it is actually 7 by 8 R. Okay, 7 by 8 R. So now I have got two things here between E and C. This is C and this is E, and I have the equivalent resistance, that is 7 by 8 R. This is a parallel combination. So now it is easy to find out. Okay, so parallel combination means multiplication by addition. So multiplication, see, 7 by 8, let me do it carefully. So the effective resistance between E and C will be multiplication by addition, 7 by 8 plus 1 by 8. This is actually R square and this is R. So this will be effectively this will be a 1 and this will be 7 by 64. 7 by 64 R square, this will get cancelled. So this will be 7 by 64 into R. Okay, so the answer is this one. Okay, 7 by 64. Okay, we'll go to the next question. So this is also from IIT JEE Main 2019. Okay, all right, let us read this problem. A uniform metallic wire of resistance 18R is bent into an equilateral triangle. Then the resistance between any two vertices of the triangle. This is also similar problem. Look, this one. If the whole wire was 18 and it is broken into three equal parts, so it will be actually 18 by 3. This will be 18 by 3. This will have resistance 18 by 3. So that means 666. Uh, all the sides will have 6 ohm resistance. Now I choose this A and B, these vertices. Now look, actually when I choose these vertices, just connect a battery over here like this. So you look, these 2 points are common. Okay, these 2 points are common, these 2 points are common here. That means these two guys are in series and which is parallel to this guy. Okay, that means I have one resistance 12 ohm, another one has 6 ohm, and they are parallel to each other. Okay, 6 ohm. So these are very simple problem. So RAB will be multiplication by, this will be final ohm, addition. Okay, so this is 18, this is 72, and this is 18. So effectively it will be 4 ohm. Okay, so 4 ohm. All right, let us go to the next problem. So this is also from IIT JEE Mains 2019. Okay. A copper wire is stretched to make it 5% longer. 5% longer. The percentage change in the electrical resistance if its volume remains unchanged. Look, percentage change means I have to find out del R by R, okay, into 100, which will give you percentage change in the resistance. Okay, so this is what we have to do. Now, what is the percentage change in the wire? Length of the wire is already given. This is given as 5%. Okay, this is given. Now look what we know. Resistance R is equal to rho L by A. Okay. Now here volume remain constant means L1 A1 would be equal to L2 A2. Okay, from here we can just find out the length, etc. Like the final length, if it is given, then we can find out the final area, but we are not going to do in that way. What we'll do, we'll just multiply length both in the numerator and denominator so that there is no change in the expression, but it looks this. Okay, rho L square by V is constant, both the cases it is constant, so I have got an expression for this. Now see, if I just take logarithm f as you have done ln, let us take ln r, so rho and v are constant, right? So ln rho plus 2 ln L, and this can be taken as minus also, doesn't matter, because this V and rho is the resistivity and V is the volume which is constant. So if I just take this derivative, so this is 0 plus 2 delta L by L, and this is again plus or minus, anything is 0. So we have got expression for delta R by R. Okay, so what is the expression for delta R by R? We'll look here. Okay, so let me erase this part. Anyway, you have got the formula. Delta R by R we have already got, which we had to actually find out. Delta R by R is this. Okay, let this be also not there. Okay, this, so I'll use this portion to do the calculation part. So delta R by R into 100, that will give you percentage. So 2 into del L by L into 100, this will give you the percentage, as I said. So this is point, okay, so point, this percentage already, okay, fine. So delta L by L is given as 0.5%. Okay, so this 100 goes off, and this is becoming 1. Okay, 1%. All right, so this will give you in percentage actually. So it is 1%, and this is the answer. It was very simple. Again, we'll go to the next problem. Even this problem is also not very tough. if you remember few formula, let us see. This is also from IIT JEE Mains, as I mentioned, all are from 2019 JEE Mains problem. Okay, the mobility is denoted by mu. Okay, mobility of a semiconductor is defined as the ratio of the drift velocity to the applied electric field. Okay, we know mu Vd drift velocity is equal to mu into E. So that means mu is equal to drift velocity to the electric field. This is what we know. All right. This is given in the problem. Okay, if for an n-type semiconductor, the density of electrons is this. That means n is given as 10 to the power 19 per meter cube, and their mobility mu is given as 1.6 meter square. This. Then the resistivity of the semiconductor you have to find out. Where, since it is n-type semiconductor, contribution of hole, because you know a semiconductor has both hole, so hole density and electron density both are there, but for n-type semiconductor this density of hole is much less than the density of the electrons. That's why contribution towards the current or electricity will be predominantly for the electron density, not for the hole density. Okay, that is what is given. Now look what we know. Current density J is equal to n E. N is the number density, E is the electronic charge, and Vd is the drift velocity. Now if we put the value of, like if we put what is drift velocity is mu into E, we'll just put it here, mu into capital E. That is also there. Okay, now look one more thing. According to Ohm's law, we know J is equal to sigma E, right? So if I put this as equation number 1 and this as equation number 2, so from 1 and 2, what we can say is sigma E is equal to n E mu into E. This E can get cancelled. Now this, we have to find out what is the resistivity. Resistivity is actually reciprocal of conductivity. This sigma is conductivity, so it will be actually 1 over n E into mu. Therefore the resistivity will be 1 over n into E into mu, which is 1 over n is the number density of electron, that is 10 to the power 19. E is the electronic charge, that is 1.6 into 10 to the power minus 19 coulomb, and mu is already given, which is 1.6 again. Okay, this as a whole will give you ohm meter resistivity, ohm meter unit. Okay, and if you see this will actually cancel each other, so here it will be 100 divided by 16 into 16, so this will be 25 4. Okay, so it is actually 25 by 64. Okay, so if you further simplify this, will be nearly 0.4 ohm meter. 0.4 ohm meter. Okay, so this will be the correct answer for this case. Okay, you can do the calculation part and see. Let me check. This is electron density fine. Mu is this, Vd, mu Vd, and E is the electronic charge. Yeah, these are all right. Okay, we'll move on to the next problem. So here we see the figure where there is a battery and there are resistance R1, R2, R3, R4, R5, R6. These are connected with this battery. Now you have to actually find out what is the current in this circuit drawn from the battery. This is actually, you look, it will be very simple problem. If you look this R2 branch, this one, this branch, so this guy is actually in parallel with the whole this thing, right? So actually R2 is parallel to R3 plus R4 plus R5. Okay, parallel to this guy R2. So let us find out. R2 is actually given as 10 ohm. So 10 ohm is parallel to, so see R3 is how much? R3 is 20 plus R4 is 5 plus, and, and R5 is again 25. So this guy is actually 50. Okay, so you have parallel combination of 50 and 10. So equivalent resistance will be how much? R equivalent will be 10 into 50 multiplication and divided by 10 plus 50. Okay, so this will be this, and you can see that this is 500 divided by 66, so it is actually 25 by 3. Okay, so now I have got an equivalent circuit. See, I'll just draw this equivalent circuit after doing this particular operation. So I have now see, up to this, we have got the value of this combination, that is 25 by 3 here I'm writing. Okay, and this is anyway R1, and this is R6, and this is the equivalent one, and this is plus minus C. Okay, look, this is R6. Now see, are all of these are actually in series with the battery. Okay, in this case the battery value is given as 16 or 15. I think it is 15 volt. Okay, so let us see, finally R equivalent will be R1 is 15 ohm. This is 25 by 3 ohm plus, so R6 is actually 30 ohm. So as a whole, so this will be 45 plus 90 plus 25 divided by 3. So we can see this is 70, so 5, 5, 10, 6, 7, 70 and 90. That means 160 divided by this. Okay, 160 divided by 3. This is the equivalent resistance. Okay, now I have to find out what is the current. Current will be obviously E by R equivalent. E is actually 15 and this is 3 by 16. So this is 5 threes and 5, 3 and 2. Okay, it is coming like this. 9 by 32. Let me check whether we have options. 9 by 32. Yeah. So this is the option. Okay. So this is the correct answer for this question. So this also was from IIT JEE. I'm just writing main 2000 main 2019. Okay, let us go to the sixth problem. This problem is also very interesting problem and also from main 2019. Main 2019, JEE Main 2019. Okay, so this problem, let us see the for the circuit shown with R is equal to 1 ohm, sorry, R1 is equal to 1 ohm, this is 1 ohm, R2 is equal to 2 ohm, 2 ohm, R2 is 2 ohm, here also 2 ohm, E1 is 2 volt, E2 and E3 they have the same voltage, that is 4 volt. 4 volt. Okay, now you have to find out the potential difference between A and B. You look, this is A and this is B. Okay, so you know, if we try to draw an equivalent circuit diagram for this guy, you look, I'll just keep A and B over here. Suppose this is A and this point is B. Now we draw all the components. Okay, let us draw this. See, A has positive terminal, B has negative terminal, along with a resistor. Resistor, if you draw here and here, doesn't matter. Okay, now look, this guy R1, that means I can just say there are two R1, right? So 2 ohm. So this is actually R2, that means 2 ohm. Here again, if I draw this particular part, okay, see, this is 2 R1, that means I'll write 2 ohm. Obviously there is battery which is connected to A as positive and B. This is the battery E1. Okay, this is E1, this battery, and equivalent resistance 2 ohm. So this is the kind of circuit. And similarly, if you draw the other one, see, R1 and R2, R1 and R2 is R1 and R2, that means 3 ohm. You draw it here. and positive is with A. This is 4 volt. E3 is 4 volt. Then E2 is 4 volt, and this is 1. Sorry, this is also 2 volt. EU1 is 2 volt. So this circuit can be actually then thought of so this circuit can be thought of this circuit can be thought of parallel combination of cells, parallel combination of 3 cells with their internal resistance. Their internal resistances, internal resistances. Okay. So look for internal resistance. See, when we have to find out the potential across this, then we have to actually find out generally VAB can be found out by total this EMF by the resistance. So equivalent this by equivalent resistance. Okay. I'm sorry, this is no. This is equivalent anyway. This is equivalent to so I can write this as I equivalent by R equivalent, and this can be again written as U1 R1 divided by E2, sorry, plus E2 by R2 plus E3 by R3 and divided by R1 plus R2 plus R3. Okay. Oh, I'm sorry, these are also parallel in series. These are also parallel. Resistance are also parallel. So 1 by R1 plus 1 by R2 plus 1 by R3 like that. So I have in the uh, equivalent circuit, see E1 by R1, that is actually E1 by 2. So E1 is actually again E1 is given as 2 by 2. So that will be 1 plus E2 by R2. R2 is here, E2 is this one. So 4 by 2. So it will be again 2 ohm, sorry, 2 volt. That is also not correct. This is in the terms of current, so 2 ampere, and this is E3 by R3. E3 by R3 is this, and R3 is actually 3. So 4 by 3. Okay. 4 by here 4 by 2. So R2 is 2 volt. Here R2 we have to take care. In all cases the resistances are half. Anyway, I think I have written down something wrong. Maybe this is 1 ohm itself. Okay, so then it is also 1 ohm. So therefore this will be this 4 by 4. 4 by 4 means 1, and here down 1 by R1 plus 1. R1 is actually 1 ohm. These are all 1 ohm. That means 1 over 2. Oh no, this is 2. This is R2 is 2. This is also 2 plus half. Okay, so this will actually give, this is 1, so 2 by, so this will actually be 10 by 3. Okay, 10, and this is 3, this is 1, 4, 8. Okay, just a minute, I'll just go to the next page and then do the calculation part. Next page, let us say this here. Okay, so VAB has to be EAB also, that is the I equivalent by R equivalent. Okay, I equivalent will be E1 by R1, E2 by R2 plus E3 by R3 divided by 1 by R1 plus 1 by R2 plus 1 by R3. So this equivalent circuit, as I showed you actually, that can be thought of, that can be thought of, that can be thought of 3. This is also 2 ohm. This is also 2 ohm. Okay, this is also 2 ohm. So all the battery, there are batteries with internal resistance 2. That is 2 ohm. So that's why we had to do this. So E1, E1 has E1 has potential 2. So 2 by R1 is again R1 is 1. In fact, we have to see the equivalent. Okay, let me just do it here. Equivalent circuit has actually, this is E1 R1, E2 R2. So these are all 2, 2, 2, and these are, this is 1 and this is, okay, so this is E1, E1, that means battery 1 has voltage 2 volt. Okay, 2 by 2 then. Okay, these are R1, R2 and R3. These are having actually same resistance, equivalent resistance. These are 2 ohm. Okay, so that's how we can actually do it here. 2 by 2 plus 4 by 2 plus 4 by 2 divided by 1 over R1 is 2, R2 is also 2 plus half. Okay, these are 3 by 2 half, and this will be actually 2, 2 and 1. So 2 to 4, 5 into 2 divided by 3, so 10 by 3 volt. Okay, 10 by 3 volt, and we have to see whether there are options. Actually, there were options for this problem. There are options. I'll clean everything whatever I have done. So options are A is equal to 2.7 in ampere. B is given as 2.3. C is given as 3.7, and D, that is given as 3.3. Okay, D is 3.3. 3.3, and we have got answer 10/3. So this is the correct answer here. Okay, we'll have last question, one last question. This is the circuit. In this circuit, you have to find out the potential difference between A and B. So here you have been given the options: 3 volt, 1 volt, C is 6 volt, and D is again 2 volt. Okay, now you have to find out the potential difference between these two. Let us say this and these are the A and B terminals. So in this case, you can see here that if I just do D and C, this equivalence, if we can find out the equivalent potential for this particular part, okay, first of all, then it will give my answer. Okay, see, if I write this VAB as E1 by R1 plus E2 by R2 E3 by R3 divided by 1 by R1 plus 1 by R2 plus 1 by R3. So in that case, what will happen, so this is E1 is 1, R1 is 1 plus E2 is 2, and E2 R2 is again 1 itself. Now this has battery, this and 1. Okay, in the denominator, so this will be 1 over 1, 1 over 1, 1 over 1. So here it is, these are all 1. So 1, 2, 3, 6 by 3. 6 by 3 gives you 2 volt. So this will be actually the potential difference across A and B. Okay, 2 volt will be the answer for this question. Okay, so with this we will stop it here for today. We have many more problems on this chapter. Actually, we'll try to get the advanced level questions also for this chapter, and then conclude it. Today we'll stop it here. Thank you for your patience. Bye for today.